Here's a video overview of my solid state coil. It's built into a computer power supply case. At the back here, I've got the standard power supply case IEC jack for the computer power supply cord. There's the two. I left in all the filter caps and capacitor and resistor that were on it. And so the power section comes into these two capacitors here and diodes as a set. They are a voltage doubler, so they take 2 times the peak voltage of your wall outlet, which is 169 volts, to double that to about 340 volts DC. That comes over to these two sort of smoothing storage capacitors, and then go to the bridge from there. It's a half bridge of mini block IGBTs. I've got CT on the base of the secondary coil, so the little wire comes off the base of your secondary, comes through the CT to ground, right to ground in the wall plug socket, and I've got an extra ground there to ground it to a target or whatever. And then that provides the feedback through a DC blocking cap and 2 clamping diodes to a hex inverter that inverts and reinverts the signal to clean it up and square off the wave to give a nice clean waveform for the 2 UCCs that give the GDT the signal to turn the IGBTs on. When you wind these, you want to make sure that whichever wire you put to the gate on one, you want to switch the wires around on the other one, so that when one's turning on, the other one's turning off, and vice versa. Otherwise, you get shoot through, and that's bad things happen. On the low voltage side, I got the power coming to a low voltage transformer feeding the driver board through the 5 volt and 12 volt regulators for the 5 volts and 12 volts for the logic chips. And here you can see is a fiber optic input. I've got a power LED and a signal LED on there. Now let's so this is what the driver board looks like, not in the enclosure. And this is basically what the interrupter is. It's 2 555 timers, one for the pulses per second and one for the pulse width. So that's built into this here. Got a power LED and another LED that flashes with the beats per second and the pulse width. That comes through this plastic fiber optic cable here, giving the signal to the board. It's actually flashing. Yeah, sorry, I printed out a bunch of boards. I haven't used them all yet. So that's a quick look here. Oh, one other thing. You gotta make sure which way your primary goes. It is very important which way this goes, and it's good to have a variac during testing, so you limit the amount of voltage coming in, just to make sure you've got the polarity right around your primary, because if it is wrong, you will blow up your IGBTs. So I have these phased with a heat shrink, so I know when I take it apart which one goes where. So I hope that explains some of it for you.